Hey guys, in this video I will show you my full review of the Tronxy X5SA 3D printer kit. Stay tuned! Now first things first, let's open the box and see what we have inside. We have some test PLA, tools, paper clips, power cables, AC cord, USB cable, power supply with acrylic enclosure case. It's all wired up with the on-off switch and fuse, and power supply is 360 watt with auto load fan. We got some blue stripes and a micro SD card with USB reader. Next we have a huge 330mm MKA3 heated bed with a pre-soldered wires and cable chain. This heated bed is a dual power, so it can be used with 12 volt or 24 volt power supplies. Thermistor wire is on the corner of the heated bed, which should be good, as it will read the temperature across the whole surface instead only in a center like on the most 3D printers. But I don't like how the thermistor wire is only held with this blue tape. This is not the best solution, and I will use some thermal paste and a heat resistant tape to fix this properly. Next there is a built-in surface supplied, which is nice. More in a package, we have all metal extruder with a nice strong spring, some cable housing, hot end wiring, it's all pre-installed, that's nice, and comes with auto level and the cable chain. All aluminum extrusions are protected with this plastic foil, which is nice, and when you peel them off, all extrusions are nice and clean. Motherboard and LCD with a touchscreen are pre-installed in this metal housing. The Tronxy X5SA used the 32-bit GTF mini motherboard with some nice features like touchscreen support, resume printing if the power is lost, auto level, filament runout switch. There is options for Wi-Fi connectivity. It has the USB plug and micro SD card reader. Next we have some Z bearings and parts. X and I carriage is rolling on these roller bearings, and we have some more frame parts. Now before the build, here is a quick look on the micro SD card that comes with a printer. There is instructions, software, video and picture, test G codes and a part list. Here is a quick look on the instructions, how to slice the model, software, there is a video and a picture how to install the timing belts, and so on. To assemble this printer it took me around 3 hours. Instructions are decent, but not the best that I've seen, but you get the idea how to do it. All the parts fit nice, and I didn't have too much hassle with the frame and the components, but it did take me another extra hour or more to do the cable management, as the manual did not tell you where exactly you should gather all the cables after when you plug them. And there is a plenty of cables on this 3D printer. Now when I connect all the wires and the components to test them, I did discover a few things that is important to point out. The maximum temperature of the heated bed that is readable from the thermistor is the 75 degrees. And the constant load is 13.4 amps or 160 watt, which is just half of the rating of the power supply. That's not the issue. The issue here is that in reality the temperature of this heated bed is 88 degrees, because the thermistor is mounted on the corner of the heated bed and not in the center. So this does not tell you the real and accurate temperature. You could relocate the thermistor, but I do recommend installing the heat bed insulation, which will let you reach much higher and precise temperature than now. And one more thing that is very important to point out is that this 16 gauge wire that's connect power supply, motherboard and heated bed should not carry more than 10 amps continuous load. Peak load that I measured on this wire was 16 amps and the continuous load is 13.4 amps, which is a bit too much for these wires, and they get warm to the touch. They will not burn as the silicon housing is rated for 100 degrees, but they will transfer heat to the motherboard and the power supply, which is not good. Now there is a few solutions to solve this issue. You could add at least one more 16 gauge wire to spread the load and lower the heat on these wires. Another option is installing the heatbed MOSFET, which is easy, safe and cheap solution if you're planning to print with a high heatbed temperature for the long periods of time. Also, like I said, There is no heatbed insulation under this huge 330mm heatbed, so the half of generated heat is wasted, so placing the insulation underneath would help a lot of warming up times and easier than maintaining the temperature. Temporary fix could be to print with a lower heatbed temperature, and you could place the wires inside the aluminum extrusions and the whole frame will work as a huge heatsink. That's what I did for temporary solution until I installed my heatbed MOSFET and heatbed insulation. Now this kit also comes with this blue stripe, which you can add on the frame, or you could have it all black, it's up to you. And this is how the Tronxy X5SA looks when it's fully assembled. Now let's run some specs and do the overview. This 3D printer has the core XI arrangement, which means that the X and I axis moves and the heatbed stay in a place and drops down on the dual Z axis, which is more stable solution, and it should have the better print quality at the higher speed because of the reduced mass on the I axis. The frame is made of aluminum extrusions 20x20 and the 40x20. It feels very stable and solid. Build volume is a large. It's a 330x330 by 400mm on a dual Z axis, so it's a slightly larger than the CR10S. It has the Bowden style extruder, all metal. Underneath is a filament runout detection switch, spool holder and the power supply. There is a nice cable chain for the old cables from the hot end and for heated bed, which I do like. And there is some acrylic parts like this stepper motor bracket, which I don't like. They should be made of metal so they can transfer heat to the frame. There is some cables that are way too long, which I don't like, but at least they are back on the motherboard case so you don't actually see them. Most of the cables you can wrap and the rest of the cables you can place inside these extrusions and secure them with the cable ties so they are not visible. When it comes to the standby noise level, it's not too bad. I'm standing next to the printer and 90% of the all noise is coming from one fan, and that's the fan on the back of the motherboard housing. Adding some nice quality fan can make this 3D printer very quiet, as when this printer is working there is no annoying high-pitched sound from the stepper motors like on some other cheap 3D printers. On the front we have a touch LCD screen. It's very nice and responsive. On the main screen there is 3 icons: System, Tools and Print. If we click here on the system, we have the info, about, we can change English or Chinese, we can adjust the screen, there is a Wi-Fi information. If we click here on the tools, we can see the manual, we can move the printer. Here is a preheat, we can set the temperature, we can unload or load the filament, we can level the printer. There is a fan options, so we can set the desired fan speed. We can stop all the task. We can set Z offset, and that was tools. If we click here on the print, we can go down and up and choose the G code that we want to print. We just click on it and you just click play here. And here you can continue for the last task or you can just start the print. On the screen while printing, you can see the temperature of heated bed, hot end. You can see the remaining time, past time, what is your speed when you're printing. You can see the file name which you're printing. You can pause the print, stop the print, see the percentage, and if you click on the tools, you can change your speed, feed rate, cooling fans, and etc. This 3D printer has auto leveling, and this feature is activated all the time during the print. We don't need to do anything in the start G code. Once you set your Z offset and press the auto level icon, the printer will take points over the whole heatbed surface and save the coordinates and Z offset in the memory, and then you are ready to print. For slicing your model, you can use the different slicers, but I do recommend the Cura or the Simplified 3D, as both have CR10 printer settings and you can use them for this printer as well. The settings that you should change is X and Y axis size from 300 to 330, and you should increase the retraction distance and speed. For printing, you can use even the default settings and you will get a decent print quality. Now my first print did not came out very well, as one of the belts came loose, and the belts that I supply with this kit are cheap plastic type belts that stretch, and it's quite tricky to tie them correctly. I highly recommend that you change these belts to the rubber belts like I did. During my first test print, I noticed something about these bearing points where the belts slide. Washers that is supplied with this kit is a spring type washer, and no matter how hard you screw them down, they will never stay completely flat and level. This causes belt to slide up and down during the print, and the belts rubber on this bigger top and bottom washer, which create a drag and rubbing sound. After I changed all washers from spring type to the normal type, belts was nice and level. This easy washers change, combined with the new rubber belts that don't stretch, created much smoother belt movement, less stress on the stepper drivers, motors, and much better print quality. After these changes or the small upgrades, I print 3D Benji 4 more times, each time in a different layer height. They are all printed with the same print settings, just with a different layer height. For example, this one is printed in 220 microns. It looks pretty good. This one is printed in 200 microns or 0.2 mm layer height. It looks very nice. This one is printed in 100 microns. It still looks great. All the details are there. There is no under extrusion. Feed rate is good. Cooling is good. No issues whatsoever in 0.1 mm layer height. Very good results. And this last one is printed in 50 microns or 0.05 mm layer height. It looks good as well, even if I don't think that too much people will print in such a high resolution on this machine, but still it's good to know what results they can expect. After these nice results, I decided to print this very cool 3D model. This is the foldable robot R that I purchased for $449 US from 365 Lab. I use gold PLA. It's a very cool to watch this Core Xi 3D printer when it's printing, and I gotta say that the stationary heated bed who drops down on the double Z-axis is a very stable during the printing than the heated bed on other 3D printers, which is moving forward and back on the I-axis. Not to mention that the printer is quieter too because of the reduced mass on the I-axis, and time lapses looks much better. Now this is how this model looks when it's printing, and it should be folded into robot. Maybe using a little bit of heat is a good idea. His arms are movable too, but after a little bit of force. And legs move too. And here is how the robot looks in a close detail. All the details are nice and present, even on a 0.2 mm layer height. It's a very cool looking model and interesting design. I do like it. Now for my next test print, on a Thingiverse website I found this great looking pine cone lamp from the Street Fire Industrials, and I load some white PLA and print all 3 pieces. Speed that I use here to print this lamp was 40 mm a second, temperature on the hot end was 197 degrees and 45 degrees on heated bed. All 3 parts came out perfectly, and for assembling this lamp you will need the A14 fitting, cable and A14 LED bulb. After some modification, here it is. It looks very cool even without any lights. Very nice details and very nice design lamp. And this is with the lights on. I use 4W LED bulb. Maybe using even 2W will give more discreet look, but even so I think it's look very good. A very cool looking lamp for sure. Now for my next print, I wanted to print the foldable robot again, but this time in a bigger scale. The color of the filament that I use was the yellow gold PLA, but I made 2 mistakes with the print settings. First, I forget to lower the hot end temperature in a simplified 3D, which was 210 degrees for the first layer, and I left it for the rest of the print, and 210 degrees is way too high and it leaves a lot of straining over the whole model. My second mistake was that the percentage of the infill I lowered from 20% to only 10% to save the filament, which is way too low for the size of this model. Printing took almost 20 hours, and after around 20 minutes of cleaning the stringing of the model, this is the results. I barely fold this model into one piece using the heat gun, as the side panels are very weak and hollow. It looked decent, but not even close like the first robot that I print in 100% scale and on 195 degrees on hot end and 20% infill. So since my first bigger scale print was not printed in a way that I like, I decided to print this pyramid and I scaled it up until it stretched close to entire heatbed surface. I did not need to use any rev here since the auto level worked so well on this printer, and my first layer was perfect over entire build plate. Speed here that I use was 50mm a second on both inner and out walls, and the temperature was 205 degrees on a hot end and 45 degrees on heated bed. The cooling fan was set on 50% and the layer height was 0.25mm. I did not want to use the vase mode to save print time, as for the size of this pyramid it could be very brittle, so I just used the 2 parameters on the wall and the 3 parameters on the bottom. The printing took 28 hours to complete, but the result was fantastic. A beautiful huge pyramid. It looks so nice and it's so well printed, and I like the color too. A very nice print results. Now just for comparison, this is the pyramid that I print with the Tivo Michelangelo, and this is the pyramid that I print with this 3D printer. A huge size differences. Now for those who wanna print ABS with this printer, I don't have such a good news, as reaching the minimal 100 degrees on heated bed is pretty much impossible without any upgrades like heatbed MOSFET and insulation, so ABS prints will warp. This is the close look of this dragon hairpin that I print in a black ABS. It is warped slightly, but the rest of the prints look good, as this model is not that tall in a Z-axis, so you can get the decent results, but you do need a few upgrades if you wanna get the better print quality for ABS. The best heatbed upgrade is the probably solid state relay with the AC silicone heater and insulation over it. I installed this upgrade on my CR10S and I can reach and maintain over 130 degrees in just a few minutes. I already brought all the components for this 3D printer as well, and I will install them on my printer later after this review. And since this 3D printer design is a cube-like, I was thinking to close the sides with the plexiglass and make an enclosure for the printing ABS, as the all stepper drivers and the other components will be outside of the panels. That makes even better and easier to make enclosure, as you don't need to think that something can overheat and get damaged. For those who wondering about the print quality at higher speed, like always, I print my fabled mobile stand in 100mm a second print speed on inner and out walls and 200mm a second travel speed. The results are pretty good, but I do think that adding the better duct nozzle could even make better results, as this one is blowing air more behind the nozzle than underneath. And here is a close look of the mobile stand and what results that I get. I use here the simplified 3D, as the latest version of Cura it doesn't have such a good results as the simplified 3D on this particular model. And now for my final test print, I wanted to print something cool, something that I never print before. I was browsing the Thingiverse and this catch my attention. A remix of the T800 Terminator Arm. As a kid, I was a huge fan of the Terminator movies, especially the second part, so this project was perfect. It took me more than a week to print all parts, sand them, paint them with the primer and the chrome paint, and I drove more than 60 kilometers to buy IKEA glass tube and lights that was required for this project. And since I didn't like the changes of original T800 Arm design and lack of some parts like thumb support, biceps extension, lack of the cable housing and etc., it took me extra day to design, make modification to finish this T800 Arm to look as much as possible to the genuine one from the movie. The results are beautiful, and this printer prints all these parts without too much of the hassle. Printing took pretty long time, as there is over 125 pieces that is on this model. Some bigger parts are printed in 0.2mm layer height and some in 0.15mm layer height. This T800 Arm is for sure my favorite 3D model that I printed so far. It looks very cool. And when you add another source of light from above, like this small LED flashlight, it looks even better. I gotta say that I'm very happy how this project turned out, and thank you Wafa for remixing this T800 Arm, and I wanna thank you the Karman Steel for designing this model and make this project possible. And now, the final words. Well, I gotta say that I like this 3D printer a lot. It has plenty of nice features, Core Xi design, solid metal frame, large build volume, good print quality, and it comes with an affordable price. But that's not all why that I like this 3D printer. I like it because this is such a good platform for future upgrades. I already have some upgrades in mind, like installing the high power AC heated bed, insulation, bare air duct nozzle, I will close sides to make enclosure, and more. With a few upgrades, this 3D printer will easily outperform other 3D printers at much higher price points. I will make another video about the upgrades for this 3D printer for sure. Links of this 3D printer as well with the upgrades parts you can find in the video description. I hope that you liked the video, thanks for the watching and I see you next time. Bye bye.